Hello everybody and welcome back to the Hybrex cultivation system. Today we're going to be talking about boosting your soil's fertility using compost and manures. So why are we focusing on compost and manures? Actually, this is one of two lessons that will focus on ways to boost your soil fertility without using conventional fertilizers. Now, we've talked a lot about the importance of soil biology and how that is often underestimated and how chemistry is often prioritized in conventional farming and gardening, and even to some degree in organic farming and gardening. Now, we all know that plants need nutrients to grow, and we want to be able to provide plants with all the nutrients that they need. One way to do that is to start with a really great soil, but as we've discussed, you have to build your soil into a living soil that has all the biology that is needed to make sure that the plants can readily uptake the nutrients. And another consideration is that when you harvest your plants, you are removing nutrients from your farm or from your garden. And so those nutrients do need to be replenished somehow. And the best way to do that is with organic matter, because organic matter contains all the nutrients that plants need and it contains the biology. So when we talk about compost and manures, we're really talking about this broadly as a way to encompass all non-liquid amendments and top dresses that you can add to your soil. And we separate them into these kind of two categories of compost and manures because there's some key differences between the two, but both of them are adding organic matter and they're adding key nutrients that the plant needs in small enough amounts that they're not going to burn or overwhelm the plant. So the big difference is that compost, finished compost, will never burn your plants, and so you can never add really too much compost. Manure, on the other hand, if it is too hot, if it's too high in nitrogen, it does have the potential to burn your plants. And in fact, manures that are high in chemical elements like nitrogen can have some of the same detrimental effects on the soil as conventional or chemical fertilizers do. So we generally want to use manures sparingly. And the other difference between the two is that compost is organic matter that has decomposed. So that means it's typically done so in an aerobic environment where microbes have broken down the organic material from more complex molecules into simpler compounds, versus manure has gone through a process of breaking down as well, but this is through digestion. And digestion is always anaerobic because it takes place inside an animal's stomach. And so there's different types of microbes that are breaking that down and different types of compounds that result. So first we'll talk about the different types of manure and how to use manure to build fertility in your soil. So we'll talk a lot about livestock manure and the different types of livestock that people commonly keep and how you can use those different types of manure to add fertility. We'll also talk about a few other types of manure that you may not think of conventionally as manure, but in fact they are. The first one is insect frass. Insect frass is essentially the excrement of insects. And so insect frass is typically produced with black soldier flies, which are really good at eating and breaking down food scraps, and then their resulting excrement is a really great fertility source, and it's natural and a lot like worm castings, has a lot of great microbes in it. Then of course there's worm castings, which we talked about in the last lesson. Worm castings are amazing because they're full of nutrients, they're full of microbes, and they will never burn your plants. You can never have too much of them. And then finally, another type of manure is what's referred to as green manure. We touched on this when we talked about cover cropping. Green manure is just simply green grass or green plants that have been cut down and are applied to the soil or turned into the soil and allowed to decompose. And they're called green manure because they contain lots of nutrients, especially nitrogen. And so in that sense, they act a bit like a manure. They are not, when they are added to the soil, they're not already decomposed. So they do need to be decomposed by soil microbes, and so that's where turning them into the soil can help, but you can also leave green manure to decompose on the top of the soil as well. Alright, so we're going to talk about a couple different categories of livestock manure. The first is herbivores. We're actually going to break livestock manure down based on what the livestock are eating, because what they eat determines really what they poop out and what that manure is composed of. So herbivores, as we know, are eating just a diet of plants. Now these include groups like ruminants, so those are cows, goats, and sheep. Ruminants are the type of animal that has 4 stomachs, as you may have heard of. And this ensures a really thorough digestion process. In fact, the digestion of ruminants is so thorough that it will kill off weed seeds, so you don't have to worry about weeds sprouting out of this manure. As opposed to other manures that are not as well digested, you may have to worry about weed seeds. Then there's the next category we call semi-ruminants, alpacas and llamas primarily. These animals actually have 3 stomachs, so the digestion is not quite as thorough as a ruminant, but it's still more thorough than humans or other animals that only have 1 stomach. Then there's a group of animals that produce manure more as pellets as opposed to cows, which is typically just a big glob. But the manure that comes in pellets from goats and sheep and alpacas is just a little bit easier to work with, oftentimes easier to transport, easier to incorporate into the soil. And then we have another category, which is primarily horses and rabbits. Now these animals digest their food the least, so both horse manure and rabbit manure will actually still have a lot of undigested, undecomposed plant material in it, which is what makes it a great fertilizer, especially the rabbit manure. We touched on this before, but you also don't really have to worry about rabbit manure burning plants. Horse manure can be applied directly to the field, although it is a little bit higher in nitrogen, and again, because it's not super well digested, you may have to worry about weed seeds. So it might be a best practice to compost horse manure first, or at least to let it age some. So all of these herbivores generally produce what we call a cool manure, which means that, relatively speaking, it's not very high in nitrogen. So you don't really have to worry about these manures burning your plants. They can be applied directly to the field in most cases. Again, some risk associated with that, but generally speaking, if you needed to, they could be applied directly to the field. Then we have our next category, which is the manure of omnivores. Now, you may not necessarily think of pigs or poultry as omnivores, but the fact is they are eating both plant material and living creatures, usually in the form of insects, but living creatures nonetheless, and so they are omnivores. Their manure tends to be more hot, so you typically do not want to apply these manures directly to your garden or to your field. They should be composted first and will need to be combined with some materials that are higher in carbon to balance that carbon-nitrogen ratio. And we'll talk a bit more about balancing carbon-nitrogen ratios when we get to the composting section. Bat guano is another manure that is pretty hot, pretty high in nitrogen. Bat guano is oftentimes turned into a powder and used as a fertilizer, just like a conventional fertilizer, because it is so high in those nutrients. And chicken manure also is pretty high in nitrogen as well. Now it's interesting, back in the 1800s there were actually wars fought over bird guano, seabird guano, because it was so valuable as a fertilizer. It was actually mined off of island rocks in the Pacific. So it's interesting because even though this bird guano and bat guano, they come from a natural source and they do have some beneficial microorganisms in them, they are so high in these nutrients that applying them directly is really like applying a fertilizer. And again, we know that fertilizing plants rather than adding organic material to build soil health can have some detrimental effects on the soil, and ultimately is probably not going to lead to the high Brooks plants that we want. Now, humanure is an interesting category here. A lot of people get grossed out by this idea, but you can in fact use humanure, manure from humans, to fertilize your garden. And it is a really great source of nutrients. The main issue with humanure and why a lot of people don't talk about using it as a fertility source is because there's a big potential to spread pathogens here. More so than animal manures, because there are certain pathogens that animals have that humans can't get, although that's not always the case. But if there are pathogens present in the human manure, it's very easy to pass those on, and especially if you put that on your food garden, that could be problematic. So human manure can be a really great resource. You just have to know what you're doing, compost it really well, and as an extra precaution, it's often good to apply it to something like fruit trees rather than to a plant that you might be growing directly on the surface of the ground, like lettuce, that could accidentally get some manure on it, possibly pass on a pathogen. And then finally, carnivores, as you might expect, have the hottest manure. And when we talk about carnivores, the ones that most of us have experience with really are dogs and cats. We don't necessarily think of them as carnivores because we feed them food that we buy at the store, but that food is composed of animal parts, and so dogs and cats both really are carnivores. It's typically not recommended to use their manure as fertility, even though you may have a lot of it. Again, because there are actually some pretty nasty pathogens that can be passed on to humans from dogs and cats, and so you want to be cautious about that. But it is possible to use these. Again, you just have to know what you're doing and be very careful about it. So let's talk a little more specifically about how to apply manure. The general rule about applying raw manure is to use it sparingly. As we said, there are some manures, a few, that you can apply without really worrying about burning. But even some of the cooler manures, like cow manure, you can potentially over-apply that and burn your plants or cause runoff. So all of this should be done with caution. Now, there are regulations in organic agriculture that actually give a guidance to apply raw manure no less than 90 to 120 days before harvesting a crop, just to ensure that that manure has time to decompose, to work its way into the soil, and importantly, to make sure any pathogens, potential pathogens, get killed off. So this is the guideline for applying to food crops, especially for crops that are actually touching the soil. Again, a great example of that would be like lettuce or spinach, something that's low to the ground and is in direct contact with the soil, versus something like corn, which the edible part of the plant is growing well above the soil and it's not in direct contact with the soil. So the guideline for direct contact with the soil is 120 days, but for non-direct contact, it's 90 days. So that's a guideline in organic agriculture, and you could choose to follow that in your garden just to be safe if you wanted to. Now, you can either mix the manure into the soil, or you can just top dress it on the soil. Either one works, but mixing it into the soil, and if you're trying to practice no-till or low-till, you can just till it into the very top few inches of the soil. This will help it to decompose and integrate into the soil a bit faster. And again, just to remember, really the best practice with manures is to compost it first. So next we're going to talk about how to integrate manures into compost. So what is compost really? You've probably heard this term thrown around a whole lot, and there may even be some confusion about what compost actually is, as opposed to soil. Oftentimes people use the word soil and compost interchangeably or to describe the same materials, which is not necessarily the case. But compost really is just decomposed organic material. As opposed to soil, which we know contains a mineral component, sand, silt, and clay, compost is just pure organic material. And finished compost is organic material that has been fully decomposed. So, what can you use to make compost? Well, really, anything that was once alive. And that's what we mean when we say organic material. There's some confusion around that term organic too, because a lot of people think of it as meaning certified organic. But organic just means anything that was once alive. And so organic material can include food waste, yard waste, crop residues, and manure. and really anything else you can think of that was once alive. So all of these things can be put into a compost, and in the end, after the decomposition process happens, which we'll talk about how to promote that decomposition, you end up with a stabilized organic material. The most stabilized organic material is referred to as humus. So this is organic material that's really been fully decomposed. It's black, it's earthy looking. You've seen it before if you've seen really good dark compost. Now there's also some confusion around the word compost because there really are many different ways to compost. Probably the best known method is the hot composting method, where your organic material heats up to the point where you often see steam coming off of it. Or if you were to reach your hand inside, it will be really hot to the point sometimes where you could even burn your hand. In fact, their compost piles have been known to start on fire in certain situations, although that happens pretty rarely. So this is hot composting, and there's mainly two ways you can do that, with a windrow or with a static pile. And then there's cool composting, which actually doesn't heat up. This is just an alternative way of decomposing organic material. The most common way of doing this is with bokashi. Bokashi involves using a microbial inoculant ahead of time to put the right bacteria and fungi into the organic matter and to have it start decomposing in a cold way, more similar to the way leaves might decompose on a forest floor. In order to get that hot compost, you actually have to have a critical mass, a pile of compost that is big enough for it to heat up. And in fact, it's interesting, but hot composting is something that doesn't occur very often in nature. Cool composting is actually more common. Again, the example being leaves or other plant material decomposing on a forest floor. That happens in a cool manner. So we can do it the cool way, we can do it the hot way. The great thing about hot composting is that it's guaranteed to kill off pathogens. It's also an aerobic method, so your resulting compost is well aerated, and in that respect it really mimics a good soil organic material. With a cool compost, on the other hand, it tends to be less labor intensive. There's not as much turning involved. But on the other hand, you don't have the guaranteed kill of pathogens and the guaranteed kill of weed seeds. Now, it can be tricky doing home hot composting to actually get your pile up to the temperature that you need and to ensure that the entire pile has reached that temperature in order to kill pathogens and kill off weed seeds. So in commercial composting operations, they've developed methods that do this very well and ensure that the weed seeds and the pathogens are killed. In fact, there's regulations that require them to do this. And it is possible to achieve with your home compost. It's just a little bit more difficult. So we'll talk a little bit more about different home composting methods in a bit here. One that I just want to highlight right now, if you look at this picture on the bottom, this is kind of a hybrid composting method. It's called a static pile. And it actually does heat up, so it is a hot composting method, but it requires less labor because you don't actually turn this compost pile. It's static. What you do instead is you put this tarp over it to keep moisture in, and you add an inoculant to it like bokashi. And when you do that, you can actually get that pile to heat up and to compost, and you don't have to be turning it all the time. So we have a worksheet that includes more specific instructions on how to do that static composting pile. So you can take a look at that if you want to learn more about it. So these are kind of the basic universal instructions for how to go about composting. There's a few key concepts that you've got to keep in mind. So the first one is having the right carbon to nitrogen ratio. Or the way a lot of people think about it is combining your greens and your browns. Another way to think about it is a combination of high energy materials and bulking materials. So really what we're talking about here is the high nitrogen, that's the greens, those are the energy materials, and the high carbon materials are the bulking agents, or the browns. Now, the whole green and brown idea can be a little bit misleading, and it does confuse people because the materials that you're using are not always green and brown. And in fact, there are a few exceptions to this rule that contradict the green and brown rule, like manures, for example. Manures are typically brown, but they tend to be higher in nitrogen. So a way that I like to think about it that I think is actually a little more helpful is dry materials and wet materials. Most of the high nitrogen materials you'll be working with, food scraps and manures, are wet. On the other hand, the high carbon materials are typically dry. Woody materials, dry leaves, paper, all that stuff is high in carbon and it's all dry. Now, the ideal carbon to nitrogen ratio is about 30:1, and in a minute here we'll look at the carbon to nitrogen ratios of some common materials that you would use to compost. But so first step is to get the right carbon to nitrogen ratio. Roughly speaking, doesn't have to be perfect. The closer you get to that, the better. You can compost with a higher carbon to nitrogen ratio, with more carbon. It just means the process will go slower. And you can also compost with higher nitrogen material. However, you run the risk there of it getting too hot or of it going anaerobic. Because again, those high nitrogen materials are often wet, and too much water will cause anaerobic pockets, which you typically don't want, at least in a hot composting system. Although, again, we have different composting systems. In a cool composting system like Bokashi, this is not as much of a concern. So, second step is to mix well. You really need to make sure that you've blended the materials thoroughly. Another way to do this that's a little bit easier when you're making a big compost pile is to do layers. So you can do a layer of carbonaceous materials, a layer of nitrogen, high nitrogen materials. But really the best practice, if you can, is to thoroughly mix these. Now, some optional things you can do are you can inoculate your compost, as we mentioned, with, say, a Bokashi inoculant, or we'll talk about a few other inoculants in a bit here that you can use. And there are also certain helpful additives that you could add to your compost, which we'll go into more detail on. So, after you've mixed well, added your optional inoculants or optional additives, then you want to get it wet. If it has a lot of dry material in it, make sure that you add extra water to it. You want your material to be wet enough that if you pick up a handful of it and you squeeze it, you can get a few drops of water out of it. If you get a stream of water coming out, then it's too wet. And if you don't get any drops of water, then it's too dry. So get it wet and then let it set, which just means leave it. It's got to do its thing, do its decomposition. If you're doing a non-static hot composting system, then you're going to need to turn it sometimes as frequently as daily. But when you're not turning it, just let it set. And the quickest compost will be done in anywhere, well, Bokashi can be finished in about 2 weeks. The quickest hot composts will typically take about a month, and sometimes your compost pile can take as much as 6 to 9 months to finish if you have too much carbon, or if you're doing more of a static pile system. It will take longer, but it will also be less labor. So here's some carbon to nitrogen ratios of some of the most common materials that people will put into their compost. We also are including a worksheet that has this chart on it, so you can refer back to the chart in the worksheet. You don't have to come back here to the video. And so as you can see here, we've listed these in order of high carbon to high nitrogen, and we've inserted the ideal compost ratio in there, which is about 30:1. Now 30:1 or something close to that is typically good. So if you're trying to get a balance of materials here, you could go to the extreme and have wood chips or sawdust combined with urine, which are the highest carbon and the highest nitrogen materials, and actually putting those two together in the right ratio can make a good compost. Or you can do something like mix a straw that's relatively high in carbon, like rye straw 80 to 82:1, dead leaves 80:1, wheat straw 80:1, stuff like that, with a higher nitrogen manure source like goat manure or poultry manure. So that's another way to do it. And then you'll see that some materials like cow manure and horse manure and alfalfa hay are actually pretty close to that ideal ratio. And so you can compost those materials just by themselves without really having to add anything else, and you'll be close enough to that ratio that it should work well. Vegetable scraps, even though they have a 20-to-1 ratio, they do tend to be wet, so you'll want to add some drier materials with that, like straw or some woody material. I've found that straw and dead leaves to combine with vegetable scraps really work the best. And so here's a list of the additives and inoculants that you can add to your compost. Now, some of the benefits of this are that the inoculants will tend to speed up the composting process. So adding a source of lactic acid bacteria is really great. And you can make lactic acid bacteria, otherwise referred to as labs, at home with some pretty simple materials. You can find instructions for this online, and we will talk about this a little bit more in the next lesson. You can also harvest what's called indigenous microorganisms and add those to your compost. And this is a concept from Korean natural farming, or just from natural farming. The idea is that by adding those indigenous organisms, you're going to get a compost that's really well suited to your environment, and it'll be kind of like a super compost. It's really going to help your soil take off. Now, making indigenous microorganisms, or IMO as it's referred to, is a multi-step process. There's actually 4 main steps to it. Again, you can find instructions for this on the internet, or you can take a class from Chris Trump Natural Farming. He actually teaches in detail Korean natural farming techniques, including IMO. Again, it is a fairly lengthy process, but if you're doing it on a small scale and you're really committed, it can be a great way to make your garden take off. And then there are some commercial inoculants that can add lactic acid bacteria. EM1 is a well-known one, and Bioflux, the product that we make, also contains quite a bit of lactic acid bacteria. Lactic acid bacteria are going to actually help speed up that decomposition process. So that's really the main benefit of adding an inoculant, and a commercial one like EM1 or like Bioflux can just be bought off the shelf and you don't have to bother with trying to make them. Now, some of these different amendments can be useful to add to your compost. Kelp meal is great microbe food, and it can help to supercharge your compost. Crustacean meal like crab meal or shrimp meal is actually a source of additional nutrients, and it's a source of what's called chitin, which is a really great substance for preventing parasitic nematodes from attacking your plants. You can add things like bone and blood meal, which do tend to be a lot higher in nitrogen, so if you need a nitrogen source and you don't happen to have it available to you, that's a commercial source that you can add. And then oyster shell is great because it's a high source of calcium, and it's been recognized that calcium is oftentimes a limiting nutrient in some types of soils. So adding some additional calcium can be helpful. Now, just another quick plug for Bioflux here. The great thing about Bioflux is that we actually incorporate most of these amendments into Bioflux along with the lactic acid bacteria, and it's all fermented, so you get a plethora of different microbes and some different nutrients that really work on the soil in a very holistic manner. And being in a liquid form, it's very easy just to add to your water and to apply it to the soil. So, how do you know if your compost is finished? This is very important to determine because actually an unfinished compost can be a danger to your plants. If compost is not finished, it will actually consume nitrogen and rob that nitrogen from your plants. So you want to make sure that your compost is finished. So there are a few ways to do this. The main one that I recommend is what I call simply the smell test. So finished compost is going to have a very earthy smell to it. And another way that you can test this is if you get some of your compost, you can put it into a sealed plastic bag and wait for about 3 days. And when you open that back up, if it smells rancid, that means your compost is not finished. On the other hand, if it still has that earthy smell, then that means your compost is finished. Now that's really one of the simplest ways to tell if your compost is finished. You can also tell based on temperature. An active compost pile is going to be above 100 degrees. Once that temperature drops down to more like room temperatures, then you can be fairly confident your compost is finished. Another thing to look for is just, are there any organic material components that you can still identify in the compost? Can you see food scraps that you can still identify? If so, your compost is definitely not finished. You want something that is really uniform and homogeneous looking. Now, there could be certain exceptional materials that take extra long to break down, but for the most part, if it's a soft organic material and you can still identify it, then your compost is not finished. And finally, if you want to be super certain and you have the budget for it, you can send your compost off to a lab and they will give you the carbon to nitrogen ratio of your compost. Now, a finished compost is actually going to be around a 12:1 ratio. Remember that we started with somewhere around 25 or 30:1 ratio. So in the process of composting, you're actually losing some carbon and adding some more nitrogen so that the finished compost is about a 12:1 ratio. Alright, so practically speaking, how can you implement compost at home or on your garden or on your farm? So one of the most common systems for home composting is this 3-bin system that you see here. So the idea is that you really have 3 different stages of your compost. You have one pile that you're adding material to actively. You have another pile that you've finished adding your material, you've just closed it off and it is composting. And then you have another bin that is finished. Now, the reason for separating this is to make sure that your compost is relatively uniform. You can do a single bin system like the one you see down at the bottom here. The only problem with this is that you're going to have a combination of finished compost mixed in with your brand new food scraps, so it's going to be really hard to filter out the finished compost to use that on your garden. On the other hand, if you have a lot of worms in your soil or in your garden and you want to feed the worms at the same time, you can put a half-finished compost, top dress it on your soil. The worms will come and eat that, turn it into worm castings, and the component of the compost that is finished will get incorporated into your soil. Now, I would only recommend this with a cool compost. If you're hot composting, you don't want to do that because the hot compost will potentially rob nitrogen from the plants. But with a cool compost, you can potentially do this. And the difference between having a hot compost and a cool compost with this kind of system is really just the size of your bin. So the critical mass for your compost pile or your compost bin is about a cubic meter or a cubic yard, essentially 3 feet by 3 feet by 3 feet. That's the critical mass to get hot composting to start happening. If your bin or your pile is smaller than this, then you're going to be working with a cold composting. Now, with these bin systems, there's a lot of different ways to design them. You may want to consider designing one that you are able to turn, that you're able to open up and have access to turn. So that's, some people design the bins so that they can be open from the front. Some people design them just to be open from the top. And you also want to make sure that you have plenty of aeration in these bins. So you can see that one on the bottom is composed of boards with separation between them. You can also use wire mesh. That's something that allows air to get in. Now, another method for home composting is with one of these bins that you can actually turn it. Now, you can purchase these bins. They tend to be a bit expensive. You can also make one yourself if you're handy. 55-gallon drums are a great material to start with. But if you have the budget and you want to buy one of these, they can make your life a lot easier. Essentially what you're doing here is you're adding your food scraps to one of these chambers here, and then every time you add something, there's a lever that allows you to spin this. The spinning action does your mixing for you. Typically these systems are insulated so that they will keep the heat in, because the goal of the system is to hot compost. And the best ones will typically have 2 compartments, so you can have one that you're actively adding material to and one that you're not adding material to. There are some brands of these that are better than others. If you look up John Kohler and Growing Your Greens, he actually has a video where he reviews different turning compost systems. So that's a really great resource if you want to get one of these. Or again, you can try to make one yourself. And so here's our cool composting methods. Now, as I hinted at earlier, You could have a cool composting system that just simply consists of a bin that's not going to get up to critical mass, that you're adding food scraps to, and if you add some finished soil or finished compost to that mix, the microbes from that compost or from that soil will help to decompose that material. However, a potentially more effective way to do this static composting is by adding a bokashi inoculant. So the cool thing about bokashi is that you don't have the same kind of limitations of what you can add to your compost. The recommendations for most compost systems are not to add meat, not to add dairy, and not to add bones. These are materials that are harder to break down in a home composting system, but with bokashi, you actually can add these materials to your bokashi bin. So it's a little bit more versatile. Every time you add something, you're going to add some of this bokashi inoculant, which is going to start growing. It's going to jumpstart the growth of bacteria and fungus on your materials. You can get one of these specialized bokashi bins here that you see on the left. It has 2 compartments because with bokashi, you will start to get quite a bit of liquid. It's actually a relatively anaerobic process, and if you're adding mostly food scraps, you're going to get a lot of excess liquid. That liquid will start to drain to the bottom, and so with bokashi, you need a way to drain that liquid out of the bottom, otherwise it will get too anaerobic. So you can do that with just a 5-gallon bucket and create your own little nozzle or spigot on the bottom, or you can get one of these specialized bins which creates a separate chamber for you, and you can just turn it and empty the liquid. Now that liquid is a bit like a compost tea. It's also a really great probiotic nutrient for plants. So you can apply that liquid while you're waiting for the bokashi to finish. And then once you've had about 2 weeks of the bokashi composting, they actually recommend that you then add that to either another compost pile or put it directly into your soil and let it further compost for another 2 weeks. Essentially what you're doing with bokashi is you're pickling your food scraps. So they will not be fully decomposed by the end, but they will be very well primed for decomposition. And it's a static system that you can keep in your kitchen. Adding bokashi inoculants also reduces the smell. Now another static composting method you can use that we mentioned in the last lesson is a worm bin. Worm bins are great because it's great to make your own worm castings, but they are a little bit more finicky. You've got to be careful what you put into them. You can't put meat or dairy or citrus into your worm bin, and you've got to make sure that the moisture level is balanced so it doesn't get too wet. So typically people will add some paper to their worm bin to balance it out. Not if you just add food scraps, you're going to get too anaerobic. And you can buy worm bins online, or you can design your own worm bin. You'll want to make sure that it is well aerated, and typically you'll want to harvest the worm castings from the bottom, so it's best to have a way to remove those worm castings from the bottom and to continuously add your fresh food scraps to the top of the bin. And finally, if you don't have the materials or the space, or for whatever reason you just don't want to do compost at home, then how do you source a good quality compost? Well, for that we recommend that you go small scale and you go local. And this is important because, again, you want to make sure your compost is rich in biology. Commercially produced composts that often come in bags or that you buy in bulk are going to be strained of larger materials. They will have been sitting for a while. They may have dried out, and so they're not going to be super high in biology. And they're just generally not as high quality as a really raw local compost that's full of biology. Might have some larger particles in it, but those are still good organic matter that will continue to decompose. Another thing you want to look for to see if the compost is good quality is, does it have visible contaminants? And when we say contaminants, I mean like pieces of plastic or stickers from produce. Those are hard ones to get rid of. Unfortunately, a lot of municipally produced compost will often have these kinds of contaminants in it. And while they're not necessarily going to harm your garden, it's just not going to look great, and it's a sign of a lower quality compost. Another thing you'll want to ask about for the compost is the source material. What was it made out of? Again, if it's a municipal compost and it's made out of food scraps from local restaurants, there's a risk that it might have chemical contaminants in it, could have antibiotics in it. It could have other stuff if you don't. Unfortunately, if you're dealing with that kind of municipal waste material, as much as we support that kind of recycling, it does typically mean that you're going to have a lower quality compost. Again, another way to check the quality is the smell. Does the compost smell rancid? Does it smell earthy? That's what you want. Or does it have no smell? If it has no smell, it means that it's not necessarily a bad compost, but it's also probably not alive anymore. And then also see how it feels too. Does it feel earthy? Does it feel moist? Or is it dry and does it feel like sand? If you look at these two pictures here, I bet you can guess which of them is the better quality compost. You can see with the top one, it just looks dry and like it's gonna sift through your fingers if that person was to separate their fingers. Versus the lower one, you can tell it's a little bit more moist, it's a little more earthy, and you might imagine it has that earthy smell to it. Alright, so that's it for composts and manures. I hope now you understand how to use these two great sources of organic material to add fertility to your garden. And in the next lesson, we're going to talk about how to use liquid amendments, ferments, and teas to also boost the microbial activity and the fertility in your garden or farm or grow. So thanks, and we'll see you next week.